So there's a question, a static charge distribution produces a radial electric field which is given by E vector is equal to electric field is equal to A into e to the power minus br upon r square, and it also has been asked to find out the charge density and total charge. And here one thing you have to remember, A and B are constant. To find out the charge density, we can use the Poisson equation, that is our del dot E is equal to rho upon epsilon naught, where rho is the charge density. And now if we integrate rho over the entire volume d tau, we can get the total charge. So for find out rho, we can use rho is equal to epsilon naught del dot E, this letter equation 1. And now we have to find out del dot E, which is equal to del dot A is a constant which is outside of the integration, to the power minus br r cap upon r square. Let this as a first function or A, this is a vector or B, let it say P, this is our vector B. We can use the properties of the nabla operator, that is del dot E of B vector is equal to del of P dot B vector plus P del dot B vector. This is gradient of P dot with B vector, P into divergence of B vector. So you can use this formula here to break this operator. So we get del dot E is equal to, so I can write gradient of e to the power minus br dot r cap upon r square plus e to the power minus br del dot r cap upon r square. The logic is to put this as a vector, which we know the value of this type of functions. There is a del dot r cap by r square. This is a well known thing, and it comes everywhere in electrostatics where the potential is zero. Potential is diverges at some point. So del of e to the power minus br, this is nothing but e to the power minus br into minus b of r cap dot r cap on r square plus e to the power minus br. And this type of thing we always encounter in electrostatics where the potential is diverges at a point 0, because this type of thing is a field which diverges at r is equal to 0, and when you take the divergence we will get 4 pi direct delta of r, because it will be diverges at r is equal to 0, so direct delta peak also associated with r is equal to 0. So now what do we left? So now we left del dot E del dot E is equal to A into, so from this we can get minus B e to the power minus br, and r dot r is 1 because r cap is a unit vector, and we got from here is minus b e to the power minus br upon r square. So A into minus b e to the power minus br upon r square plus, from this we will easily get 4 pi result of r e to the minus br, 4 pi result of r e to the power minus br, and rho is equal to epsilon naught del dot E. So I can write rho is equal to epsilon naught del dot E is equal to A into epsilon naught. This is our total charge, which is a charge density. and it has a property that this type of charge is distributed at r is equal to 0, and this type of thing is like a surface charge density. Now we have to find a total charge. Total charge is equal to rho d tau integrating over the volume v. So from the first thing you get a into epsilon naught, which is comes outside the integration, because these two things are constant. So now this is a radial distribution, so I can use the property that is for the radial distribution. You can write d tau is equal to 4 pi r square dr. We can write volume element like this. So what I left is r varies from 0 to infinity because the volume integration over the all space. So r varies from 0 to infinity minus b e to the power minus br from r square into 4 pi r square dr, plus again this is the all space integration over the space 4 pi delta of r e to the power minus br 4 pi delta of r e to the power minus br into beta. From the first integration we left a into epsilon naught minus d will be outside the integration, and this will r square can 4 pi is outside the integration, and we get e to the minus br upon minus b, limit varies from 0 to right plus, and if you do the integration of this part, this will just resulted 4 pi, and direct delta of r is from this direct delta function we got the peak at r is equal to 0. This will be, we can use the property that is the f of r direct delta of r d3r, which is resulted f of 0. So you can use this property here, and so from the above integration we can get 4 pi e to the power minus b and r is equal to 0, so 0, and there is a into epsilon term, so a into epsilon 0. This type of term will came, and minus b cancel out, so 4 pi a epsilon naught, this is e to the power minus infinite minus e to the power 0 plus, and here we get 4 pi a epsilon naught, e to the power minus 0 is 1, e to the minus infinity is 0, so we get minus 4 pi a epsilon naught plus 4 pi a epsilon naught, which is equal to 0. So we get total charge is 0. So this is the solution of this question. You get charge distribution as a into epsilon naught minus b into e to the minus br upon r square plus 4 pi delta of r e to the minus br. So this shows that this type of charge distribution where delta is associated is at the center of the r is equal to 0, so the center of the distribution, and this type of thing is spherical charge distribution, and the total charge is always 0.